And again, if we hit play right now, absolutely nothing will happen. So let's incorporate the first real bit of programming in here and give our ball an artificial force. We're going to manually set some sort of force on the ball to get it moving. And we're going to write our first script. To keep the project organized, I'm going to shrink down materials. You know what? I'm going to put the physical materials in there too, even though it's not quite the same. I'm going to go and create a script. And a lot of people, when they start with Unity, start with JavaScript. The fact of the matter is, JavaScript and C#, there's not a tremendous deal of difference between one and the other. It might be slightly easier to find Unity tutorials and examples written in JavaScript than C#, although oftentimes you'll find both. The documentation certainly has both, including the Boo script. The advantage of going with C# is C# is actually much more widely supported in general, and if you're looking for a greater career, C# is probably the sort of skills you want to practice. The other thing to note about JavaScript, it's not real JavaScript, it's not normal JavaScript, it's a variant people refer to as a Unity script, because it's not quite the same. So anyway, I like to use C#. I think it's well worth doing. So this is, by default, called new behavior script. We will call it simply ball script. You can call it anything you like. And we're going to create a folder to keep all our scripts in. So this is going to be the script that pretty much has all the behavior for our balls. That sounded a little bit dirty. One thing to keep in mind, if an object is going to have complex behavior, and especially behavior shared by multiple objects, some of you may be thinking, I can use multiple inheritance or something like that. Don't do that, but do use multiple scripts. For example, you could have one script for things like that you're going to use all objects that have hit points are going to have a sort of hit point script or a health script applied to it. And that gives it like, oh, well, it'll start off by setting the hit points to 100, and then it has functions to receive damage and maybe heal and give various feedback and things like that. And that is entirely separate from the script that says, I respond to keyboard input and move around. That way you don't have just one big monolithic player script and then you have another monster script that duplicates half your code. Instead, you share the code. Both players and monsters will use the hit point script, and so on and so forth. This is, of course, a much simpler project, so it's not going to be much of an issue. So let's double-click on this to open our ball script in MonoDevelop. And I just have to slide it over from my other monitor here and do some awkward resizing. So MonoDevelop is the editor that comes with Unity 3D. You can also use Visual Studio Express, or potentially any version of Visual Studio. But most people, I think, probably use MonoDevelop. It has better hooks into Unity. For example, if there is an error in a console log, double-clicking on the line in the error should open it in MonoDevelop and have the exact line selected. I don't think that happens in Visual Studio. So here is our script. It's got a little bit of fluff auto-generated. If you do generate a JavaScript file instead, you probably won't see this fluff, but the fact of the matter, it actually does still exist behind the scenes. And usually when I'm programming in JavaScript, I actually end up writing this anyway, just to make it explicit. If it's missing, it'll fill it in for you, but I like having it explicitly. So very simple. It starts you off with two separate functions, one that will run at the start of the program, and one that is run every single frame of animation. All we're going to do is we're going to want to add a force to our current object. Now, our object, our monobehavior object, has a variety of member variables and functions already incorporated into it. One example of a variable that is here is it automatically has a variable filled out for your rigid body. Every controller that you see here on the right has an accompanying variable that controls it. For example, something as basic as the transform, which is your position and rotation, that exists. We can go transform dot position dot x, right? And then you've gotten your x coordinate. And that includes our rigid body. And we're going to add force to our rigid body. And there's a few different ways that we can pass the force. We can instantiate a vector3 object, or we can just feed it some coordinates directly. And you know what? I'm just going to do that. I'm going to apply... Actually, you know what? Now we'll do it this way. We're going to apply a force to start off with that goes straight up. So we're going to go 0. We're going to set a force. And I think these will have to be fairly large numbers of like 1,000. Make it a float. And 0. And then close that off. So I'm just going to save this. And I'm going to tab back over. I've got a lot of windows open to Unity. It should auto-compile it. There's nothing in the console, no errors. The status bar down here would also show you errors from the console. And now if I play, well, nothing's going to happen, actually. Nothing at all. The reason is there is no gravity on the ball, but I also haven't put the script on the object. The script is just one of my assets right now. It's not actually in use. So once again, I'm going to take the ball script. I'm going to drag it onto the ball. And now if I click on ball, you can see there's a ball script applied to it. And if I hit play once more, there we go, it got a force applied to it. Apparently, I got the direction wrong. I didn't realize that 1,000 would be going down. Oh, no, okay, I think, so I was right. Positive numbers are up. I think it just happened so fast that I missed the first bounce. There we go, slowly starts to go up, and then stops. Why did it stop? I'm actually genuinely confused about this. It didn't stop here. I think it failed to bounce somehow. Something with the materials, maybe? I have to be honest, I really, really did not expect that to happen. I think it's just going too slow. Let's take a look at the physics material. Is there anything we can do to fiddle with that? Is it friction, maybe? I think it may have been the friction that caused it clamping. Let's take away all the friction from our ball and see what happens. Still. I think it's just a minimum speed, and when it's bouncing. What if I go into the project and go into physics and just apply our mega bouncy physical material to literally every object in the game, and by making that the default. Just to make sure there's nothing going on in the brick. No, it's literally that it's going too slow. And I do know that that happens. If things are going beyond a certain minimum speed, the simulation has to assume at some point that things get clamped and come to a rest. And I'm willing to bet there's somewhere where you can tweak that value. Ah, the sleep velocity. I'm sure that's it. Let me bring that back down to 100. And again, if I hit play, it'll hit and then stop. But if I take down the sleep velocity dramatically by, say, inserting a 0 in front of that and hit play. Ah, not quite. Oh, bounce threshold. Let's try that one. 0.5. There we go. So that's the problem. I'm going to leave it where it is because you know what? That sounds perfectly fine. We're going to want our objects to move faster anyway. Let's pick 300 as a nice medium speed. Looks good to me. All right, so this object is going to keep bouncing back and forth because it has perfect bounciness. And awesome. Next thing we need is we need to be able to move the paddle. But before I do that, let's make it just slightly more visually appealing by giving it a slight diagonal motion. So now it should hit and then fall down, and I don't know, I find that very satisfying. All right, so we need to be able to move the paddle.